The other challenge is putting things into the context because when we started this project, we wanted to have a very holistic view, like a weather forecast, in which we take all the servers. We have more than 7,000 servers. If you take all the servers and all the applications, and you don't put things into context, you do not attach application with its servers, and you compare everything like all the servers all together without having the prior knowledge of which represents where they are hosted and how they interrelate with each other, that you are doing a very wrong analysis. And at that beginning, we started doing that, and we realized in a very short amount of time that we couldn't go anywhere with this analysis when we put everything together. So now we are putting things into the context in a way that if I'm analyzing an application, I want to map, first thing, I want to map all the servers that belongs to the application in terms of database instance, web server, and where the application is hosted. Everything that it belongs to the application, I want to see in a segregated view. And if the application is in a specific architecture, let's say Java, we can generalize, we can scale up to other Java applications. But if it's a C# or it's an old kind of application, we cannot use the same approach. We have to analyze differently and then compare afterwards with the similar architecture. That's a summary of the project. And now I'm going to compare based on the current scenario and where we want to be from now on. Okay. The current environment today rely on dynamic automation. And do you remember when I mentioned about static thresholds? Let's say you take one metric and you specify a threshold. That's what dynamic automation does. It's efficient to solve very simple problems, but when we are talking about SEV1 tickets and SEV1 related issues that needs to have a more deeper level of analysis, you raise a ticket and you have to have, you must have a human technician with knowledge to solve them, because dynamic automation does not solve those kind of problems. And in the current scenario, there's no machine intelligence applied to monitor our systems and applications. And all the data stored in monitor is not used to autonomously take decisions, as I mentioned, especially the SEV1s. And with the current approach, there are so many false alerts raised and unneeded tickets issued on SCCD in infrastructure now that we want to reduce this amount. Actually, we want to predict a failure and do a heads up to the technical users and to the ones that owns the application prior to raising those tickets, because it takes a lot of time and amount of resources to solve them. That's our main objective for this project. And with machine learning, we want to we actually have an MVP project that we autonomously detect anomalies in application performance, and we want to scale up to all the applications that are instrumented on New Relic and onboarded on Big Sky. We analyze performance data from application servers altogether to accurately determine which ones are behaving different from the norm. And how we do so, we take the density of the differentiation between one application and and the servers that the application belongs to, and compare each one in a time frame. Let's say 10 o'clock. What's the values at 10 o'clock for all those metrics, and then how they differed at 11 o'clock, and then so on and so forth. and it is so forth. And if the difference is very high, that's an anomaly. And with the history data knowledge, we want to predict a failure prior to its occurrence and recommend accurate actions to the support team. And these concise actions, it's going to go in, we have a roadmap for this project, and we want to provide recommendations and reliable actions to the user based on previous experience.